Hello everyone, and welcome to today's chem lesson. Today, we are going to wrap up our discussion on solutions by talking about concentration, which is a more precise way of knowing whether or not a solution is saturated, supersaturated, saturated with extra. Because as we saw in our video where we talked about what it meant to be unsaturated or saturated. Right? In that video, we said that 4 orange dots, 4 dissolved ions, was saturated. And that means that 3 dissolved, or 2 dissolved, or 1 dissolved orange ion was all unsaturated. And as we know, we don't like having multiple different things with the same name. And so concentration is going to come in and give us a way to differentiate between these 3 different unsaturated solutions. All right, it's a way to go more in depth on the idea of unsaturated or saturated or supersaturated. And we have 3 different calculations, 3 different things that we can do depending on the circumstances to see what the concentration is. Right? Molarity, parts per million, and percent by mass are all different ways of calculating concentration. And we're going to go through them in this order, starting with molarity. Molarity is probably the most common way that scientists talk about concentration. It's a measure of moles of solute per liter of solution, and that gives you your molarity. Now, there are difficult molarity concentrations, and there are easy molarity concentrations, and everything in between. For a really difficult one, they don't give you moles, and they don't give you liters. And you have to convert grams to moles, or whatever they give you, into moles and into liters. For this, for the top one, 80 grams of sodium hydroxide, first I need to identify what sodium hydroxide is. Then I need to calculate what does 1 mole of sodium hydroxide weigh by looking at the reference table and taking the molar mass of each atom. Then I need to say if 40 grams is 1 mole, 80 grams is 2 moles. But I'm still not done yet. I still have 500 milliliters that I need to change to liters before I can plug in and solve for molarity. This second one, on the other hand, is a lot easier. They tell you you have 2 liters of a 6 molar solution, and they want you to solve for how many moles there are. And here it's just a cross multiplication. Here we're going to get 12 moles as our answer. Because so much chemistry is done by measuring moles and counting moles, molarity is the most common thing to see. When we're talking about acids and bases, when we're talking about electrochem, when we're talking about organic chem, we're talking about molarity almost always. The other 2, which we're going to look at in a second, are much less common. So here again, our answers end up being 4 and 12. Right, 4 and 12. The second calculation, concentration calculation we're going to look at is parts per million. And parts per million has a thing for you on the back of the reference table on table T. So does molarity, so does percent by mass, right? All of these formulas exist on table T for you to just pull up and use when you need to. Parts per million is a mass over mass ratio multiplied by a million. This is used when there is a small amount of something in a much larger solution. Right, when we're calculating how much gold is in the ocean, we're calculating parts per million. When we're calculating 0.2 grams of something in a liter, that's parts per million, right? A very, very small amount of something in something much bigger. And so all we're doing here is we're taking our part, our solute, over our whole thing, our solution, and multiplying by a million, just like we did when we calculated percent water in a hydrate. So here, 0.02 grams of solute divided by 1 liter of water, which is 1,000 grams of water, plus the 0.02, right? It's solute over solution. Solution is the whole thing, times a million. Now, if you forgot to add this 0.02 and just did 0.02 over 1,000 times a million, you wouldn't get a very different number. You would get this to come out to a nice even 20 instead of 19.999, which is what comes out when you remember to add that piece. Because 0.02 compared to the 1,000 is really not a big piece of it. It's still important to remember that this is mathematically correct to do it this way, and that you're not actually, you're not allowed to just leave it off because it makes life easier. The same thing goes with this one down here. Here we have 250 micrograms, so we don't have the same unit, so we must convert so that these are the same unit. 250 micrograms is 0.000250 gram, because a micro is 10 to the negative 6. So you gotta move the decimal 6 places to convert from micrograms to grams. Divided by 4 times 10 to the 4th, it's 40,000 grams of water. And again, they say of water, not of solution, so we have to go in and add this 0.000250 to our denominator. Times a million. It gives us 0.000625 parts per million. Right, it's always part over whole times a million. We're using that to calculate really teeny tiny amounts of solute in a much, much bigger solution. And again, these answers, right? 19.999, 006, oh, too many zeros. 00625. And our last type of concentration. Okay, wait, why is the unit parts per million and not PWM? Why would it be PW? It's parts per million. Right, remember, a solution isn't always water. And so I'm imagining that that W comes from the fact that these are both in water, but these are just examples, and it's just an abbreviation of parts per million. the last concentration calculation that we're going to look at is percent by mass. Right? You have to add, okay, let's go back one more time. You have to add the 0.02 because water is not a solution. Right? Solution is solute plus a solvent. And so if you're looking at these questions, it gives you your solute and it gives you water. Water is not the solution. The two of these together make the solution. So saying the water itself isn't actually doing solute over solution, it's solute over solvent, which isn't what it says to do. Right, if this had said solution, you could have just ignored the addition piece. But because they're telling you specifically it's for 40,000 grams of water, you must add in the mass of the solute to get the mass of the solution. And we're going to see that come back when we look at percent by mass. Percent by mass is again solute over solution. It's part over whole. Instead of times a million this time, though, it's times 100. And here, with percentage, we're actually going to see a much bigger amount of solute. So here when we look, 80 grams of sodium hydroxide in 500 grams of water, if we solve it correctly, that's 80 over 580 times 100. Which is very different than if you solve it incorrectly. Right, this 80 is a much bigger piece of our solution here. And this is incorrect. Right, you must add the two together unless they tell you it's the solution. Right, so 80 over 580 is 13.79%, which is different than what it would be if we left this 80 out and solved it incorrectly. The second question really shifts our focus a little bit. It tells you 800 grams of solution. And so we know that 800 grams is our denominator. And it tells you that we have a 25% by mass solution. And so we need to solve for x in this case, which depending on how good your math knowledge is, you can just look at this and solve it out. Right, x over 800 equals 0.25. Right, so we're looking for a quarter, which would be 200. Or we can solve it out, right? 100x over 800 equals 25. Multiply by the inverse here, 800 over 100 to get 200 equals x. The last one is even trickier than the second one. Here, they're giving us almost the same information, but here they give us the amount of solute that's there instead of the amount of solution. And they ask us, again, we need to be careful, they ask us for the amount of water. Which means when we solve for x, we need to subtract the 85, because x is the amount of solution that we have. And so when we go through and we solve this one, we're going to take our 100, divide both sides, get it to go away. So we get 0.4. Cross multiply. 85 equals 0.4x. Divide by 0.4 to get our 212. Just gonna double check that number. Yeah. X equals 212.5. And again, though, we just solved for x, which is mass of the solution. We want the amount of water. We don't want solution, we want solvent. So we're going to take away our 85 grams of solute to be left with just our solvent, which is going to be 127.5. And when we come in to check these answers, we're going to see that they line up as well. All right, 13.79, 200, and 127.5. It's really, really important to recognize that solute, solvent, and solution are three different things. When they ask for how much water, they are not asking for the mass of the solution. To wrap us up, I've got one practice problem, one multiple choice taken off of an old Regents exam. And here they want you to solve for the molarity of this solution. Molarity is a measure of moles over liters. So 10 moles of copper nitrate in 5 liters of solution is going to give me a 2 molar solution. Sometimes these calculations are really simple, sometimes not so much, but you always have reference table T to look back on, and all of the knowledge that you have learned so far. With that, I'm actually going to transition us over to our Zoom meeting for questions, comments, concerns, and attendance, and I will see you there.